When it comes to air quality, we are mostly worried about atmospheric pollution. However, we're spending the majority of our time indoor. So keeping track on indoor air quality and measuring and controlling it is not a side issue. And this is especially because the air we breathe impacts how we learn, how we work, and how we relax. Luckily, there are devices such as air purifiers, which are capable of filtering out indoor air pollutants such as volatile organic compounds, short VOCs, and nitrogen oxide compounds, short NOx. And you can make your device smart by simply integrating one of our products, SGB40 or SGB41. And in doing so, you can improve for your end user the comfort by automatically triggering the device only when there is an event. You can improve the safety because our sensors also detect odorless gases. And you can improve power saving because the device will stop automatically when the event is over. Hi, my name is Oliver and I'm the product manager for our SGB gas sensors. Today it's my pleasure to introduce you to the new evaluation kit, the SEK SVM4X, which is the evaluation kit for both of our products, the SGB40 and SGB41. And I will introduce you how you can make use of it in your indoor air application. So now let's unbox it and let's have a look inside what we find. On the flyer, you find on the back side a QR code that leads you directly to the landing page of the evaluation kit. There you find a lot of information like documentation, tutorials, firmware, drivers, and many more that is relevant to developers. Most importantly, the evaluation kit features the SVM41 development board. It is equipped with an SGB41 and an SHD40 sensor. Please note, the SGB41 features all functionalities of the SGB40. On top of that, there is a microcontroller unit on the board that is helpful to process the sensor signals to the NOx and the VOC index. You can access all the signals through the Molex connector via I2C or UART interface. Another part of the evaluation kit is a jumper wire cable set. It is equipped with the matching connector so that you can easily connect your SVM41 to embedded platforms like Arduino, Raspberry Pi, or any other. Additionally, we also provide a gender changer. In order to control the SVM41 with Sensirion's Control Center Viewer software, it is necessary to use the USB UART cable, which you also find in the evaluation kit. The only point left is to download and install the latest version of the Control Center Viewer software, which you can find under the displayed link. Now we have everything we need to start our first evaluation of the sensors. I have plugged in 4 SVM41 to my computer. When starting the software, you find all 4 devices listed on the left side. On the right side, you will see now 3 panels showing the data of SGB41 and SHD40. One for relative humidity on the right side displayed here, and also for temperature displayed on the left part. Another tab for VOC, where you can find the processed VOC index signal on the top and the raw signal at the bottom. And the same configuration you can also find for the NOx signals. Additionally, I created a new view called Gas Indices, which you can find now here as the 4th tab, so that we can just focus on the index signals. In order to start your measurements, simply hit the Start button. During the first 45 seconds after startup, both index values will be 0. Thereafter, they will show values between 1 and 500. Now let's create some VOC and NOx events. For this we use a conventional gas slider and a glass. Please note that you don't execute such tests next to flammable materials. When I hit the button of the gas slider without igniting the flame, VOC gas is going to flush into the glass. And subsequently, I just put the glass on top of the sensors. In Control Center, we can see now how the VOC index reacts to this event, while the NOx index does not react at all. We repeat the same experiment. However, this time use a new glass and we ignite the flame, which will combust all the VOCs to CO2, which the SGB41 is not sensitive to, and it will produce NOx. And now we're putting back the glass on the sensors. As expected, now we see almost no change of the VOC index, but a clear event detected by the NOx index. This experiment nicely demonstrated how you can selectively discriminate VOC from NOx events by the help of SGB41. Finally, I'm going to demonstrate how the SGB could work in a real-life application. We have prepared an Arduino system here and we connected our SVM41 board. You see a disk connected to a motor that is mimicking the fan of an air purifier, which is normally used to flush the air through the filter. And you also see some indication by these traffic light LEDs that show you the level of the VOC index in this case. When I create, for instance, now a VOC event just the same way as we did it before, we will see that the VOC index is rising, indicated by the yellow LED, and the motor is starting. And when we hit an even higher threshold, then the motor will go to maximum speed. So as soon as the VOC index drops again, we see that the motor speed is decreasing as well. And once the lower threshold is hit again, we see that the motor stops. As you can see, the SEK SVM4X is the perfect tool in combination with our free Control Center Viewer software to evaluate the SGB40 and SGB41 VOC and NOx sensor products. So start your own evaluation now by purchasing the evaluation kit via one of our many distribution partners. Visit our landing page for more information. Thanks for watching, and don't forget to subscribe and hopefully see you soon.